The previous class, we have completed the two-dimensional array and its memory representation in two methods, that is row measure order and column measure order. Then at the end, we have identified the memory address of a particular element in row measure order as well as in column measure orders. So today we will conclude that arrays with the heading called as applications of arrays. Applications of arrays. Arrays are used to implement other data structures such as stacks, queues, linked lists, etc. Arrays are used to implement the data structures like stacks, queues, linked lists, and etc. This is the first application we are getting from arrays. The second application, arrays are used to implement mathematical vectors and matrices. As we have learned in C++, addition of two matrices, multiplication of two matrices in your first year syllabus. That is the application of arrays. And the last application is many databases include one-dimensional arrays whose elements are records. It means records are stored in a continuous memory locations. That's why we'll use these arrays in databases because databases stores records. The records are arranged in a continuous memory locations. That's why we use arrays as application in databases. These are all about the applications. Now we move on to the next part of array, that is advantages of arrays. It is used to represent multiple data items of same type by using only single name. Nothing but a group of elements of the same type are stored under one common heading. That is the advantage of arrays. Example, all computer science students, say common name, all the students belongs to computer science are CS students. All the elements, all the students belongs to CS, that is CS class. This is the advantage of arrays. Then second advantage is it can be used to implement other data structures like stacks, queues, linked lists, trees, etc. It means using arrays, we can implement the data structures. That's why in the beginning we are studying arrays in a data structure. Using this, we are implementing remaining data structures. Two-dimensional arrays are used to represent matrices. Yesterday also we checked that the two-dimensional memory representation, we took example as matrices. A 3 cross 3 matrices were taken as an example in row measure order and in column measure order method. That is the advantage of arrays. Memory representation of arrays in two-dimensional array can be used using matrices. So after knowing the positive side of arrays, then the drawbacks, that is what are the disadvantages of arrays. The first disadvantage of arrays, we must know in advance that how many elements are to be stored in array. It means array is of fixed size. In advance only you come to know that how many elements are stored in a array. That is the first disadvantage. Second one, array is static structure. It means that array is of fixed size. The size of the array is known in advance because of fixed size, right? It means it is array is a static structure. I hope you understood this. Then third, based on that fixed size, one more disadvantage, that is, since array is of fixed size, that is static structure, we allocate memory, more memory than requirement, then the memory space will be wasted. If we allocate less memory than requirement, then it will create a problem. We are fixing the size of the array. Assume that before using that we are fixing array size of 10 rows 10 columns. But during that problem, actual array size is of just 3 cross 3. It means we are wasting memory of 7 cross 7 of that matrix. That is one case. Because of fixed size, if you allocate more memory in the declaration, then actual size, then wastage of memory takes place. This is first case. In the second case, if you allocate less memory, example, if I allocate during declaration only the size of the array is of 3 cross 3, but actual size of that problem is 5 cross 5, then there will be a problem in the program. Program creates a problem because unable to store the required elements. Then the last disadvantage of arrays is insertions and deletions are very difficult and time consuming. Insertions and deletions are very difficult and time consuming. As you have seen, in case of inserting an element into an array and deleting an element from an array, you checked, right? The task of insertion and deletion is a tedious one, as well as it consumes a lot of time. That is the disadvantage of arrays. This completes the first main topic in the data structure, that is arrays. By using this, further data structures can be implemented. Next, we move on to the next one is called as stacks. After completion of arrays, from arrays also in the examination you'll get some compulsory questions, mainly the memory representations of one-dimensional as well as two-dimensional arrays are important. Now we'll start the next topic called as stacks. S-T-A-C-K-S, stacks. A stack is an ordered collection of items where the addition of new items and the removal of existing items always takes place at the same end. It means stack has only one end. From that end only we are adding a new item into it, or else we can remove the item from the stack from the same end. It means it has only one end for insertion as well as deletion purpose. That particular end, this end is commonly referred to as the top. The only one end which is used to add a new items or remove an existing item is called as top. Top is the end, one end which is used for insertion as well as for deletion purpose. The opposite to top is known as base. The another end of stack opposite to the top is called as base. It means stack has one end called as top. By using that top, the insertion deletion can take place. And opposite to that end is called as base. The most recently added item is the one that is in position to be removed first. It means we can go on inserting an item into a stack, and the last item which is inserted into the stack to be removed first. It means it occupies the topmost position in the stack. This follows the principle called as LIFO, that is LIFO. Stack follows the principle of LIFO, last in, first out. Newer items are near the top, while older items are near the base. Whichever the item inserted first, that is near to the base, and whichever the item which is inserted at the last, that is near to the top. After knowing this theoretical part, if you understand the concept of that, now you can observe with the help of this diagram. See here, is it clearly understood here? The diagram is very clear. Now, whatever the theory part you have learned, that you can see it here. Say, this one. This is called as one stack, right? This is one stack, just like one box is there, U shape. This is a stack. Then this is the open end. This end is the end which is responsible for adding a new item into the stack or removing an existing item from the stack. That's why this end is called as top. Stack top is this end. And opposite to it, this one, this end is called as the base. Opposite to the top end is called as base. This is base, this is the top. In stack, insertion, that you are sure. One more term we are using for insertion is push, and for deletion, a term we are using is pop. Right? The data structure, in the arrays we have used insertion deletion, whereas in data structure after the stack topic or from the stack topic we are using the terms for insertion is push, a term for deletion is pop. That's why I have shown it here. Push and pop operation can take place from the top of the stack. Then if you observe here, we have elements. The stack contains some elements. Element 1, element 2, element 3, element 4, element 5 and element 6. The first pushed or inserted element into the stack is element 1. Right? This is the first element. Then in an order we are pushed one by one. Then last element which is pushed into the stack is element number 6. The topmost element in the stack is near to the top of the stack, whereas the older element in the stack is near to the base. And this stack follows a principle of last in, first out. In short, LIFO. What is stack then? After knowing this particular explanation, if you define what is stack or define stack means stack is an ordered collection of items where addition of new items and removal of existing item takes place from the same end is called as top, and it follows the principle of LIFO. This is the definition of stack. So after knowing this, the definition as well as the explanation, now we move on to the next heading called as, that is representation of stacks in memory. Memory representation of stack or representation of stacks in memory. The memory representation of stack can be done in two ways. That is, first one is called as static representation using arrays, and the second one is called as dynamic representation using linked lists. The memory representation stack can be done in two ways. The first one is called as static representation using arrays, and second one is called as dynamic representation using linked lists. Now, we'll start with the first way, that is static representation using arrays. Array representation of stack, that is memory representation of stack using arrays. Memory representation of stack using arrays, or the static representation using arrays, or array representation of stack. One and the same. Now, stack can be represented using a one-dimensional array. Array application we are getting advantage. Right? Using array, we are implementing stacks. Stack can be represented using a one-dimensional array. A block of memory is allocated, which is required to accommodate the items to the full capacity of the stack. A block of memory is allocated in one-dimensional, then it goes on filling the elements into it until the stack becomes full. The items into the stack are stored in a sequential order from the first location of the memory block. How it stores? We are using arrays, so that's why the items into the stack are stored in a sequential order, one after the other, from the first location to the last location. A pointer top contains the location of the top element of the stack. In this stack, the pointer called as top contains the location of topmost element in the stack. A variable max stack, MAXSTK, maximum stack, that is max stack, contains the maximum number of elements that can be stored in the stack. It means this is nothing but the actual size of that particular stack. The condition top equal to max stack, the condition top equal to max stack indicates that the stack is full. When the top reaches the max stack, then it indicates that the stack is full. All the elements are filled into it. And if the top equal to null, the top value is null, then it indicates that the stack is empty. This is opposite of first case, that is if top equal to max stack, it means the stack is full, or you can say that is overflow. And the second case, if the top equal to null, then it indicates the stack is empty, or you can say that it is underflow. Now, whatever the theory you have learned concerned to the stack, that you can see in the form of diagrams here. See, memory representation of stack using arrays, that is static representation of stack using arrays. See, this is the array 0, 1, 2, dash, 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 dash are the subscript values, and the elements of that stack are 1 and 2, right? If you observe the top here, top always positions at the topmost element in the stack. That's why I mentioned here, index or subscript, these are all. Then this is nothing but the growth of the stack can be shown in this direction. It means this is the first element, second element, third, fourth, fifth, and sixth element. This goes on. It means stack grows towards right side. This is one way. And if you observe here, one more, this is stack. Nothing here in this, nothing is there in this particular stack. It means the stack is empty. When you create a stack, that create a stack is empty initially. Then we want to push an item 1 into it. That we are showing it here. We want to push, we want to insert, we want to add an item 1 into the stack. Okay, that process is done, insertion. After inserting this item 1 into the stack, this is the view we will get. See, the item 1 is stored in a stack at the 0th position. Now the top is here. Previously top was at 2 in this example. Here it is, top is at -1. Now top has reached 0th position, 0th subscript. Then again we want to add one more item 2 into the same stack. Then after inserting one more item 2 into the stack, this is the view we will get. See, this stack contains 2 items, that is 1 and 2. First we inserted 1, that's why it is near to the base, and lastly we inserted item 2, that's why it is near to the top. Now after completion of insertion operation, now if you want to perform the deletion operation, if you want to remove an item from the stack, means always you should remove the topmost item from the stack. That's why in this example, if you want to remove the item from the stack, means the item 2 will be removed first. Even if you want to remove the item 1, then also the item 2 will be removed first, then item 1 can be removed. At a time, one process can be done, that is, first you have to remove the topmost item, that is 2, from the stack, then this becomes top. Now you can remove 1 also. This is the way we will get after deletion of this topmost element from this diagram. We'll get this view. So if you want to remove 1 also, you can remove it. It means the stack contains only one end, that is top, that is responsible for adding an item into it or removing item from the stack. So this is all about the first way, array representation of stack in memory. Now we move on to the second way. The second one, the second method will continue now. That is linked list representation of stack. Linked list representation of stack. This is second way to represent stack into the memory. Memory representation using linked list here. Stack representation using linked list. The size of the array needs to be fixed. The size of the array needs to be fixed to store the items into the stack. We are discussing the first point here, the concern to arrays. In arrays, the size of the array is fixed one. If the stack is full, we cannot insert an additional item into the array. If it is array, if the stack size is full, then further you cannot insert into the array. It gives an overflow exception. If it is full means top equal to max stack, then you can say that the stack is overflow or stack is full. But linked list, in the linked list, we can increase the size at runtime by creating a new node. It means we are discussing first 2 points concern to arrays. They are the drawbacks of arrays if you compare that with the linked list. The using array concept is a fixed size, whereas if you use linked list, it is a dynamic one. Using arrays is static method, using linked list is dynamic method. If you want to insert further some more items into the stack, it is possible only in linked list because it is a dynamic process. During runtime, you can create a new node and go on adding into it. It is not a fixed one. Whereas in the arrays, it is a fixed size. Due to its fixed size, once the stack size is full, further insertion is not possible. You will get overflow message. So it is better to implement stack data structure using linked list. I hope you understood this. Array is fixed size. Once we reach the maximum size of the array, it shows the error. Further insertion of items into the stack is not possible in arrays. Whereas in linked list, it is not a fixed size. It is a dynamic process. It means it allows you to go on adding a new items into the stack during runtime. This is the advantage of linked list over arrays. See here, the diagram we have shown here, the linked list representation of a stack. These are called as, see here, 1, 2, 3 are there. These 3 are called as, each box here is divided into 2 parts, that you are calling it as a node. It means in this structure we have 3 nodes. Node 1 contains 15, node 2 is 25, node 3 is 20. Total we have 3 nodes are there. Then one start point is there, right? Then all the nodes are interconnected. One node is connected to another node by using arrows. And the start contains this. Always start is a pointer that always contains the address of the first node. This is the first node, this is second node, this is third node. In the linked list representation, the last node, right, contains null. The last part contains null. It means, just I'll give a reference for you, that the node is divided into 2 parts. First part is called as info field, that is information field, and second one is link field. Info contains the data values, datas, whereas the link field contains the address of the next node. Right? I hope you understood this. Each node is divided into 2 parts. First part is called as info field, that contains datas, and second part is called as link field. Info contains data, whereas link field contains the address of the next node. And the last node, link field, contains null. Null indicates end of linked list. Now, this completes the representation of stack using linked list. Now we move on to the next heading called as insertion. Insertion refers to inserting an element into the stack. What is insertion? Insertion is the thing which it refers to the adding or inserting an element into the stack. That process is called as insertion, or that operation is called as insertion. Insertion operation refers to the inserting an element into the stack. We create a new node and insert an element into the stack. You can create a new node and insert an element into the stack. To follow the stack principle, last in first out, a node need to be created from the end of the linked list, and element need to be inserted into the node from the end of the linked list. As per the stack definition, the node as well as the element to be inserted from the end of the linked list. Right? Now you can see here. The insertion diagram is mentioned here. This is starting point. This contains one node. Suppose if you want to insert one more node, first you have to create one new node. That node is again divided into two parts. First part is called as info, second part is called as link. Then after creating and entering data into this, now you can connect that to the end of the linked list. End of the linked list. It means this first node, initially this first node contains a null. It means end of the linked list. After inserting, this contains the address of the second node. The second node link field contains the null. It means end of linked list. Further, after inserting a node into the linked list, now you can study the deletion operation, right? How to delete a linked list. See here, deletion. Deletion operation. Deletion operation is to delete an element or node from the linked list. What is deletion? Deletion is to delete an element or a node from the linked list. Removal of element or node from the linked list is nothing but deletion. Deletion can be done by deleting the topmost item. Deletion can be done by deleting the topmost item from the stack, as the last item inserted is the first item that needs to be deleted as per stack principle. As already we know that stack follows last in first out. Based on that, whatever the number of items we have inserted, right? While inserting, we are inserting one after the other, and while deleting, this also follows the same principle, that is stack, last item which is inserted to be deleted first. So the recently inserted item, that is top item, must be deleted from the linked list to perform as stack deletion. Right? Okay, now you can observe the diagrams. The linked list representation is shown here. Start point is there, pointer is there, then node 1, node 2, node 3. 3 nodes are there. Right? Now, if you want to remove a node from this linked list, the last inserted node should be removed first. According to the principle of stack, the last inserted node should be the topmost node, that is the end node, that is shown here. The node number 3 will be the last inserted node into the stack that can be removed first, right? That's why I'm showing it here, right? This particular third node contains a null. This indicates null. This should be shifted from third linked field to second node's linked field. It means the third node is removed, because whenever you come across the null in the link field, it indicates that end of linked list. That we have shown it here. Say the null character from the node 3 will be shifting, or we are moving from node 3 to node 2. It indicates that this linked list contains only 2 nodes, because second node link field contains null. It indicates that end of linked list. Like this, we can delete a node from the linked list. So in the today's class, we have started with the applications of arrays. Then we have studied the advantages of arrays, then disadvantages of arrays. Then after completion of that arrays part, now we have started one more data structure called as stacks. In the stack, first you have completed the stack definition, then explanation part with the help of diagram. Then you have started how to represent the stack in memory representation of stack using 2 ways. That is, first way, static method using arrays you have learned, and the second one using linked list, that is a dynamic method. If you compare these 2 methods, the best method is the linked list method, because during runtime also you can go on adding a new nodes into the stack. That is possible in linked list. That is not possible in arrays because of fixed size that you have compared. After that, we have learned 2 operations, that is insertion. Insertion is nothing but adding or inserting an element or a node into the linked list. And lastly, we have completed the deletion operation. That is, deletion is nothing but deleting an element or a node from the linked list. In both the cases, the stack follows the last in, first out principle. Right? This is all about the today's class, and in the next class, we'll start with the operations which we can perform on stacks. That is, operations on stack will be continued in the next class. If you find any difficulties in this,